In this video, I'm going to go through required practical 5, which is to determine the resistivity of a sample of wire. You'll be tested on the following CPACs, 2B and 2C, that you can measure the diameter of the wire using a micrometer, and that you can use a ruler to measure the length of the wire accurately, and you can control for all other variables that might affect the resistivity of the wire during the practical. I'll also be teaching you how to use an Excel sheet to plot a graph, and finally we're going to do some research online to determine what the expected resistivity of the sample of the wire is, and then we're going to learn how to reference that in our reports. I'm going to go through how to use a micrometer to determine the diameter of the wire, and you're going to have to mention all of this in the discussion section of your report. Okay, so first of all, close the jaws of the micrometer and ensure that it reads 0. Okay, so here you're just checking for 0 errors, and the 0 should be aligned like it shows in the diagram. Okay, next put the wire between the jaws of the micrometer and use the thimble to close it like so, but don't close it too tightly, okay? Once you feel a bit of tension, then switch to the ratchet and use that. And when you hear your first click, you stop, okay? Because otherwise you're going to squash the wire and you're going to change its diameter, which is going to give you an error there. Okay, so don't just do it across one point. You're going to have to take multiple readings, at least 3, and do it in different orientations at different points along the wire. Okay, and then once you've done that, you write down all those numbers into a table and you're going to find an average. Okay, next thing is to measure the length correctly. So once you've set up the circuit like it shows in the diagram here, you've got the sample of wire here. However, if we take a measurement right now, it's not going to be very accurate because you can see the wire is bending. And if I measure the length, it's actually going to give you a smaller reading than what it actually is, because you can see if the wire is folded a bit, it's actually longer between the crocodile clips there. Okay, so what you're gonna have to do is you're gonna have to tape it down and straighten out like this. Okay, this means that we'll be able to get a much better reading for the length. Okay, during the practical, we need to control for all other variables that might affect the resistance of the wire. So one that comes into mind is the temperature of the wire. So the higher the temperature of the wire, the higher the resistivity. And we know that current in a circuit has a heating effect. So if we make, especially when we make the wire really short and we're going through a short piece of wire, then that means the resistance that we're going through is quite small, and that's going to increase the current. And if you have current that's larger current, then it's going to have a heating effect, and that will affect the resistivity of the wire. So to avoid the current changing, we're going to use the variable resistor, and we're going to keep the current at a reasonable and low value so that it doesn't cause the wire to heat up. Okay, step 2 is to make a table to record your results. First of all, we measure the diameter of the wire. So we're going to take a bunch of readings at different points along the wire, different orientations, and I use a micrometer. Make sure you write that down to the correct number of units with an average. And then before you start the practical, make sure you write down the type of wire that you use and the material that it's made out of. Because for example, I use constant tan, and you're going to use that later. We're going to research and find what resistivity we should have got. Okay, we're going to change the length during the practical. We're going to measure the voltage and current, and you're going to use that to determine the resistance at different points. Okay, so look at the data that I've used. I'm measuring across roughly between a meter, and my current, I'm keeping it constant by using the variable resistor to make sure that it's always at 0.50 amps. Okay, once you've done the practical, type up all your data into a spreadsheet like it shows here. And actually there's a mistake here. I'm going to make sure that the column here is the correct number of decimal places. So I'm going to highlight the data, and I'm going to right click on it like this. I'm going to go to format cells. Okay, then a window will open up like this. Click on numbers, and then make sure the decimal place is to the correct number of decimal places. For example, mine is just 2 decimal places, and then press OK. Okay, next, to analyze the data, I don't actually have to calculate the resistance myself. I can get the Excel spreadsheet to do it for me. So click on cell D2, like the one where you got the first resistance, and insert this formula which says equal cell B2, which is the first voltage, divided by cell C2, which is the current of the first in the first length. Okay, and then press enter, and that will give you your data like so. And you can put other formulas in here as well for future reference. So you can use slash or divide, multiply, powers, plus, negative, and so on. Once you press enter, it will show you resistance like this. And we want to apply this formula to all the data points and calculate all the resistance. So you're going to click on this tiny square at the bottom right corner here, and you hold it down, and you're going to drag it down and let go for up to the last data point. When you do that, it looks a bit like this. And now what he's done is taken the voltage and divided by the corresponding current for that particular length and has done that formula for you. Okay, now we're ready to plot a graph. To insert a graph, click on Insert there, and then click on this Scatter Graph button, and then click on this option here. And if you haven't got any data selected, it'll give you an empty blank graph like it shows in the back there. Click on the empty blank graph and click on Select Data. Right click on it and click Select Data, and a window will pop up like this. Okay, we're going to add the data in now. So click on this Add button. A window like this will pop up, and we're going to put in the X value and the Y value. So first of all, the X value, we're going to put length on the X axis. So click on this one and select the length data. So that column there, and then press OK. And so your data should look like this. Okay, and then next part, you're going to click on the Y data. Okay, so you see this cell over here, you need to make sure that you clear this. Okay, so make sure you press backspace and empty it before you start entering any data into that. So once you click on it, you should be able to highlight all the resistance, which is what we're going to plot on the Y-axis. So highlight all the resistance on this axis over here, and then let go, and it would look a bit like this. Then press OK and OK, and your graph will pop up like this. Okay, so you got a straight line, you can see, but nothing is labeled there. There's no X label, Y label, no units, the title's not clear. So we're going to simplify this by clicking on Chart Design, and you'll get a pop-up like this, and then click on Quick Layout, and Quick Layout number 9 seems to be pretty good, so choose that one, and that'll give you a lot of things, but you can choose whatever you want. But main thing is we want a trend line with an equation. Okay, so that we can use that data to determine the resistivity of the wire. Okay, here's my example graph. I've cleared it up and I've made it look neater. I've added an X label, so length in meters, resistance in ohms for the Y label, and I've got a title. I've cleared all the rubbish that I don't need, and I've just got the equation displayed nice and clearly, and that's in the form y equals mx plus c. And I've plotted resistance on the y-axis and length on the x-axis. I'm going to compare it to this equation here. Okay, so there should be no y-intercept. There is a tiny one here, but that's not that important. The error is very small that we've got a y-intercept. So the thing that's multiplying the x-axis, which is length, is the resistivity of area. So that's my gradient, resistivity of area. So therefore, the gradient times the area, cross-section area of the wire, should equal the resistivity. So cross-section area of the wire is pi r squared, or pi, and I've got the diameter already measured, so diameter divided by 2 squared. So let me go ahead and calculate that. So my gradient from the data I've got here is 15.7 pi. I've turned my diameter into meters here, times 10 to minus 3, divided by 2 to 10 to radius, and squared it. So that's my area, and that gives me a measured resistivity of 4.17 times 10 to minus 7 ohm meters. The final step in the practical is to go ahead and do some research of the resistivity that you expect for constant tan, or whatever material that you use. So I did some research. I went online and Googled something, and I found this website, and you can see the resistivity that I expect for constant tan. And I'm going to, most importantly, I'm going to write down the URL. Okay, so in my report, I'm going to write something in the discussion section. I'm going to write something like this. So my measured value of the resistivity is so and so, and on the internet I found that it should be so and so. And then you can see I put a number there in brackets, 1, but you can give whatever number you want. Now that's for referencing. Okay, I'll come back to that in a second. Another thing you can mention is the percentage difference between what you measured and what you expected. So the one that I measured, let's calculate the percentage difference. So if you subtract the difference between the one I measured and what I expected, divided by what was expected from the actual website given here, times it by 100, and I'm basically off by 15%. So I can write that in my discussion section as well, which isn't too bad. 15% is pretty good. But there's that number I told you about, and that's for referencing. That's very important, because in the reference section, because you use some number from a different source, you're going to have to mention that in your reference. So in the reference section, make sure you write something like this, which says that I got the value of resistivity from this URL. Okay, so from this link, and also in brackets you need to write down the dates that you accessed the URL. So make sure you write that down very clearly, and otherwise you will lose that CPAC.